My name is Renganarayana, LN for short. Um, my background is in building ML products and data products for almost more than a decade now. At Workday, I lead the machine learning architecture team and the data science function. So let's start with how many of you actually care about the privacy and security of your personal data? Show of hands. Great. Yes, we all care. How many of you care about the privacy and security of your customers' data? Great. So I think you are all in the right place. I do too. I care deeply, and one of the reasons I work at Workday is that Workday also really cares deeply about it and really invests a lot in actually translating that into the software and the products that we build. So with that, I would like to start with this, which is essentially the key message of the whole talk. Privacy and security are foundational for any AI, any ML products that's being built. And some take it seriously, some don't, but nevertheless, it's foundational for AI. My key thesis is a well-designed architecture can go a long way in enabling that foundation, in enabling that privacy and security. So my hope is that over the next half hour or so, I would be able to kind of walk you through our journey of starting from this premise and this belief and how we have actually built and deployed to production a platform that enables building privacy-preserving, secure ML products. So here is kind of an outline of the talk. First, I'll set the stage in terms of there are some nuances when it comes to building ML products for the enterprise, particularly the enterprise SaaS space, as compared to the consumer space. For example, you can handcraft one nice ML model and use it for all your customers in the consumer space. But in enterprise, typically you often have one per your customer, and when you have thousands of customers, just that scale itself is staggering. Then I'll set that stage. After that, I'll introduce a few building blocks. I strongly believe in abstractions that are independent of technologies that help you realize or implement these kind of privacy and security. So I'll walk you through those abstractions and then get to the concrete realization of them in an architecture with technologies from AWS and containers that help us kind of implement that platform. Then I'll conclude with a few lessons learned. So it's good. How many know? How many of you use Workday products? Okay, a few. Oh, that's great. So then probably you know already, Workday builds enterprise cloud applications, primarily in the areas of human resource management, financial management, analytics, and planning. And Workday products enable businesses to realize this virtuous business critical loop of plan, execute, analyze, plan, execute, analyze. And that generates a lot of value for businesses, and also that is at the core of the entire business flow. So that leads to the unique data sets that this generates, or this is, when I say this, the business critical workflows that our customers execute is based on the clean operational data that they actually have. One example of a business flow that they execute is payroll. Every week we all get paid when that payroll run happens. And for me, nothing can be more business critical than that. When you don't want all your employees complaining about not getting paid. So in the same sense, also, companies report their quarterly financial results from the data that they store in Workday. So you could see that this is a very clean data, not like some kind of a log data, very clean operational data that all these companies actually, all our customers trust Workday with. And more than half of Fortune 50 and more than 40% of Fortune 500 are Workday customers. These are like really big customers, starting from Amazons of the world, Bank of Americas of the world, Walmarts of the world. So you could imagine kind of the scale. It also provides us with these unique data sets that we can now use to build machine learning products and bring that value back to customers. on one side. On the other side, also it requires privacy and security to be at the forefront in protecting this kind of sensitive data. I'll introduce the ML product development flow because many of you might be familiar with it, but this provides the basis for the platform that I'm going to talk about. So the requirements when I talk about the requirements, this will kind of be a nice overview to keep in mind on what those requirements are about. So typically any ML product development starts with collecting and preparing the training data. So that's your kind of first step, get the data. Once you have the data, then typically your data science team or your machine learning engineers start actually choosing and optimizing the machine learning algorithm on it and start preparing or start actually building and optimizing that machine learning model. And once that machine learning model is actually trained and tuned, then you get into the productization part of it. You want to deploy that machine learning model to production and then scale and manage the production environment. So this is the backdrop. This is the fundamental flow for all the ML products. There could be exceptions, but this is a very good approximation for the discussion that we are going to have. So with that as a backdrop, let's actually look at the requirements. There are three key categories of requirements that I want to discuss. One is around privacy. The other one, security. The third one is as important as the previous two, which is time to market. In today's enterprise software world, time to market plays a very critical role, particularly in the speed at which ML is getting commoditized. If companies are not fast enough to bring those value based on ML to customers, there is always 10 startups that is actually aiming at exactly the same space. So time to market is as important as the other ones. The key thing is not to compromise on any one of these things. So that is the theme that you would see as I actually start talking about the design. We have consciously strived not to compromise one over the other. It's a much easier or simpler problem to just pick two out of these three and actually go with that, but not compromising on any of them and actually building a platform that would enable ML products is the hard one. So let's start with the privacy requirements. You all might have heard about GDPR, this European General Data Protection Regulation. We also have our own, the CCPA, and probably very soon Congress might have one more that is much more like across all states in the US. There are many aspects to it. I want to consider three aspects that are core to ML product development. Those three are transparency, control, and right to be forgotten. There are others that are equally important, but just to keep this talk smaller and keep it focused on the ML platform, I've chosen these three. The transparency is essentially, if I'm a customer, do I have transparency on what data the product or the company is going to use and for what purpose it is going to use? Think about all the end user license agreement we sign off when we install a new app on our phones. Do we have this transparency? Actually, no. If you really look at it, it's not clear what exact data that it is going to use, and it's even less clear for what purpose it is going to be used. And this becomes really important if we want to actually talk about privacy by design or supporting meaningful privacy for ML products. Then the control. At any time, having the control to opt in or opt out from providing that access to that data or using that feature from that service. And related to that is having a meaningful default. For example, an agreement that says, I agree, then you can use the app. If you say you don't, you just cannot use the app, is not a meaningful default. A meaningful default is like maybe a non-ML version of the product or a slightly less superior or less effective version of that product. The last one is right to be forgotten. This is essentially when I opt out as a customer, when I opt out, I would like that product or that company to erase all the data that it has about me. And this is as much for persons as it is for big enterprise customers. And it only gets more complicated in that case. But nevertheless, this fundamental requirement, this needs the ability for companies or products to be able to trace what data is used in which product or in which services across all their whole stack. And these three, if a product implements these three, already it is a good first step. Next is the security requirements. To some extent, the privacy and security go hand in hand, but encryption is at the heart of any of the product now, right? Encrypt everything is the motto. Encryption at rest and transit is common. We have seen that. And when it comes to enterprise products, the bar is higher, because the encryption is no longer just encryption, but it is encrypted with each customer has their own keys and their own life cycle of that keys and their own control of that keys. So it's encryption at rest with per tenant or per customer encryption. In addition to that, when it comes to building ML products, there are copies of the data that gets made. You want to take a data set, send it through an algorithm that builds a model, it's going to locally cache that. Being able to actually encrypt data at use, as in these kind of caches, also is as important. Then access control. So this goes towards the use of data for a given purpose. One of the requirement we saw in privacy was a customer clearly understands what data he or she is contributing or allowing access to and what it is used for. And that what it is used for also relates to who gets to actually see it. For example, for sensitive data sets, that's absolutely important to control that visibility and access to that data only to those that actually are building ML models or actually need to actually have access to that. Then always on security, this is essentially at any point of time, that data is always encrypted and access controlled. It's not, it is not like only under certain circumstances. It's also transparent to data scientists. This is an important thing. This goes towards, you might be surprised why the last point is here in the security kind of requirements. It is here because whenever these kind of security mechanisms are implemented in a way that it's not transparent, it often ends up with data scientists or programmers or application developers taking shortcuts to actually reduce the burden of actually encrypting or securing that. So making it transparent really makes it always on or always actually implemented. It also goes towards productivity. Next is the time to market requirements. First and foremost, optimize for that end-to-end from idea to getting feedback from the customer. If you remember the product development flow we saw, the entire flow starting from collecting the data, it starts with someone has a very interesting or a brilliant product idea. They want to actually build that product, get it to the hands of customer. It's only for ML and data products that first time you can get your product in the hands of the customer is when you get valuable feedback. Before that, you are only like kind of guessing that, okay, the customer is really going to find value in this product. So optimizing for that time from that idea to product is the critical productivity measure. And data science productivity itself in terms of the activity of like building machine learning models, being able to iterate very quickly on the data set as well as on various ML techniques becomes very important. And then being able to collaborate and discover, either discovering features that some other team actually uses. So this goes slightly more towards like when you have, when you are building a platform in a company like Workday, where there are lots and lots of teams actually building products for a variety of different domains, right? Like be it HR or financial, planning, analytics, there is a lot of potential for reuse of data sets, reuse of ML models, reuse of ML services. Enabling that is key. Then access to cutting edge tools and compute. ML algorithms and ML services are getting commoditized every day. Be it open source tools or be it like cloud machine learning or AI services that's available on AWS or on Google, it's getting commoditized every day. So that's really not the differentiator. It only becomes a differentiator in the sense that your data science team having access to that is critical for you to be able to actually quickly build these ML products. And then no undifferentiated heavy lifting. This is like a guiding principle for us at Workday, where we will leverage, be it cloud machine learning or AI tools or open source or wherever it is when that is appropriate for the business. We won't actually tend to or start with building it ourselves. And that goes also towards how quickly we can actually get to market. So here's a summary of the requirements. There are a few more that's there, but for this discussion, I think these three kind of carve out the space. Okay, so for privacy, security, and time to market, these forces, all of them like tend to kind of pull in each in different direction, and the trade-off that we make is what kind of carves out the architecture. Cool. So next, what I want to do is to introduce these abstractions that I mentioned that are towards actually building this architecture for implementing these requirements. The first and foremost, it could be very obvious, but it is a data set. The most fundamental thing about any ML product is the data, and having a first-class abstraction or a first-class object that captures that abstraction goes a very long way in terms of not just enabling ML development, but you'll see in terms of enabling all those privacy and security to be implemented in a very meaningful way. So data set is a fundamental abstraction, and it is abstraction that is secured, as in like that's the granularity at which we want to enforce encryption. We want to enforce access control at that level. Who gets access to that, a given data set, maybe a given data set from a given customer. Then at the heart of it, it is just a collection of data items. So you have a collection of data items that makes up that data set, and that's the unit that or granularity at which you want to secure it, you want to control access to. Then, if you remember the right to be forgotten privacy requirement, one of the key things in that is to be able to track the lineage of data. What data is used to build what service? If you just think about in your own, like kind of in your company or in the products that you build, and if you ask the question, what data is used to build what product? Can you answer that question when a product is running in production and you want to know what are all the data sets that were used to actually build that? And what changes in the data set should trigger a rebuild of the model or a redeployment of the service? It is a hard problem. And the bigger your kind of data sets and the customer base and your company is, the harder this gets. Fundamental to that is being able to collect extensive metadata and use that to track lineage. And this is the granularity at which it's meaningful to kind of do both. Collect that metadata, use that metadata to track lineage. A cousin, okay, before I go into that, I want to introduce two operations on this abstraction. One is the checkout, the other one is publish. So you can think of an analogy in terms of either like here we are treating data sets like code. You want to actually explicitly version them, and then you check out a version of that data set to build a product so that you know exactly which version of the data set actually was used to build the product. Implicit in this view is also that data sets are immutable. Once you have a data set, it's versioned and it's immutable. You just use that data set. You want to transform it, you just generate a new data set. Storage optimization, etc. can be handled, but at the abstraction layer, this provides a very, very clean way to track lineage. And the other analogy, if you want, is like think of it as an ebook that you would actually check out. Once an ebook is published, it is immutable. People can check it out, use it, and it is also, in that sense, has time to live. A particular project or a data scientist can check out, use it, and after some particular period of time, that is no longer accessible. You can control those things. It also provides the primary leverage point for access control, encryption, and lineage tracking. So what I mean by that is all uses of the data set is through these two options, the checkout operation, and all creation is through the publish, provides you the ability to transparently, for example, encrypt and decrypt upon publish and checkout. Also allows you to actually check access control when a particular data scientist is trying to check out a data set to build something. You have that leverage point to actually check access control in that. And it also provides a meaningful way to capture the metadata needed to say, this data set was created by this service at this time with these other data sets that were used to create. And that provides the foundation for the lineage tracking. So that is data set. A related cousin for that is the features, which is like, for example, looks exactly like the data set. The key difference is, given that data sets are immutable, you want to have a unit that is explicitly meant for reuse across your organization. So quite often, multiple data sets are combined to derive a feature that could be, for example, used in many, many different ML products that your company builds. And features essentially provide you that nice abstraction that allows you to capture that lineage as well as allow you to have that single unit of reuse that can be like easily, now probably you might want to index it. Index all that metadata into something like Elasticsearch, so it is discoverable by across your organization. So it provides you a nice abstraction like that. Then the next one is the model itself. That's the other fundamental unit, is your machine learning model, which is actually produced using different data sets, different features. And again, I won't dwell into the ones that are the same, right? It is secure, access control, metadata is attached to it, and lineage tracked. This is the key unit of deployment. You don't deploy your data sets, you deploy your machine learning model to production. So that way, this has additional either metadata or additional requirements on that, and also supports the operation for deployment. The last key abstraction is ML pipelines. If you look at much of the processing that happens, that uses these data sets and uses these models, is these ML pipelines. That's just a sequence of transformations. It takes the data, and there is a whole lot of processing that happens in terms of transforming them into features, using the features to build a model, tune them, and then you have a model that's ready to deploy. And this is treating this ML pipeline as a code and versioning them is what is going to really help in terms of that lineage tracking. For example, the right to be forgotten. One of the key requirements for that is implemented in 30 days. You want that data, a data that is from Bob, a data that is related to Bob, is removed from every place it is used in your system within 30 days. Imagine how you would implement a requirement like that. To be able to know that exactly this is the pipeline that uses that data to produce this model, which is in production, helps you to actually go and rerun that pipeline with a new version of the data set that doesn't have information about Bob, and then produce that model. And you might also want to actually use other properties like the ML pipeline. If it takes like 14 days, if it takes, let's say, a week to actually run, you might want to factor in that for the 30 days that you have to kind of build a new version of the model and get it to production. So with that, here is a summary of the basic building blocks. You have data sets, features, model, and ML pipelines. So with that, now the next step is I want to actually move into taking these and start mapping them into a concrete design and start introducing slowly some of the technologies that we use to implement these abstractions. And second, how all of them come together to kind of fulfill the bigger requirements, right? Like the requirements around privacy, security, and time to market. Cool. Let me check how I'm doing on time. So it's 5:15, I think I'm good. Yeah. All right. So no architecture exists in isolation. So all architectures, all systems exist in the context of a bigger system, and the ML platform is no exception. There is the Workday core transaction services that's there. Today, when you go and actually file for PTO or do a benefit election or run a financial transaction, all those things happen in the core transaction servers or the core transaction services. And then you have the application logic and the UI. All those things leverage the core transaction servers but can also benefit from machine learning. So they form the other side of the context. Then you have your security deployment, like for example, the key management infrastructure, your deployment pipelines, or your infrastructure on what it is deployed on your compute, your storage, etc. And also the monitoring and the metrics and all those things. So all these things exist as context for that ML platform that we are building. The other different kind of view on that is like the layer cake kind of view, right, of the architecture where you have, so we leverage AWS, and also we have the same thing running in our Workday data center. So that forms the infrastructure. Then the next layer on top of it is the ML data infrastructure. So all ML platforms enable or typically have a significant data infrastructure at the bottom that enables, like you saw, the transactions happen in the primary transaction servers, the application, the user interaction, etc. are happening on the UI servers and the application servers there. All those things are data sources. All those services are data sources through which you want to actually regularly get a feed of data that will power your ML models. So that's that ML data infrastructure layer. The next is essentially a set of services that provide these basic, that implement these basic abstractions, like the data set abstraction, the model abstraction, access control, lineage, etc., which is then leveraged by the actual ML tools. The ML tools like, for example, your ML pipeline that checks out a data set, uses that to build a feature, builds a model, and deploys that. And then our data scientists and other users actually are on the top of them. So that gives you two different views. The third view that I want to take you through is actually like a little bit go into deeper and start talking about how we actually implement each one of these. So the first is, let's start with data. So there are multiple data sources, like I mentioned, like the transactions happening, as well as there are also other data sources. It could be even public data sets that you want to leverage, or you want to leverage the Twitter feed. You want to get that as additional data source that you want to leverage. So there is a data ingestion service that takes all this, that is implemented using Flink, that allows ingestion, or like classic ETL, right? That allows taking this data sets, doing some transformation, massaging them, and then publishing them as a data set. So the data set service is the one that implements the data set abstraction. It provides that checkout and publish operations. And it also provides a bunch of CRUD operations, like on data set as a representation, which is used by the internal kind of services that talk to it. The data itself is stored in S3 buckets. So the data sets, as well as, for just brevity, I kind of collapsed features and data sets into one service, and I'm showing it here. But essentially, S3 buckets and together with S3 bucket policies are used to store these data sets, and also the bucket policies together with IAM, role-based access control policies, allows us to implement access control. I'll come to it in a second, but the data sets and features themselves are persisted in S3, and DynamoDB is used to store the metadata. So now if you remember the data set abstraction, the operations are like the checkout and publish, and the metadata that we collect for tracking lineage is stored in DynamoDB, and the data itself is actually stored in S3. So this gives a nice kind of very quick implementation for us. So when I talk about time to market, so we started implementing this new version of the ML platform about 9 months ago, and now it's in production, actually serving ML products. So the ability to build something like this in a fast pace like that depends on how much we could actually leverage. And that's where like AWS came in handy. You could be using any other, like it could be your own like kind of data infrastructure that you could leverage, or Google Cloud Platform, or Azure, any of them. But just kind of being able to map them into standard things like you have an object store, you have a key value store. Think of it that way. I'm using AWS examples, but you could implement them as good with a Cassandra and like maybe some other object store that you use. So that implements the dataset service, and this happens again and again and again, right? This is the primary ETL loop that brings in data and creates lots and lots of these data sets. Once these data sets are created, then we have data science or machine learning environments which implement. So this is the one where the ML pipeline is actually built. The ML pipeline that you saw, which are built by our data scientists and engineers, is essentially built in these environments, where there is a variety of things that are leveraged. One, during the initial kind of ideation and exploration stage, the Jupyter notebook-based SageMaker is actually used to actually build those initial iterations with the data and get to a reasonably good working model. Later on, it becomes more automated. When you want to actually build this for thousands of customers, you can no longer actually operate in a Jupyter kind of notebook on a human sitting there and building models. So that's where you actually automate them using something like an Airflow. You build that pipeline that can automatically check out the data, build the model, evaluate it, or tune it, evaluate it, and then it can actually publish it. So we use temporary S3 buckets and EBS that are all kind of packaged and attached into that. And the primary data flow between the dataset service and the data science and the ML environment is through this checkout and publish operation. This is really key. The data scientists or the data science pipelines, ML pipelines, do not directly access the S3 bucket, because this is the leverage point for access control, everything, access control, encryption, as well as lineage tracking. If there is direct access to the S3 buckets, all of them will break. So this is partly it is partly implemented through culture and convention, and part of it is just not giving access to anybody through that S3 bucket. So it's a combination of that, but it is critical to actually realize that. So then we have this authorizer service. That is the one that actually implements this role-based access control on. If you remember one of the privacy requirements is that a data set that is contributed by a customer for a given purpose is used only for that purpose. This is how it is actually gets implemented. For that data set, we capture metadata about which customer it belongs to, what feature was it actually contributed for, and then that is actually used to authorize that checkout. If this team that is actually going to check out this data set is the one that is building that service, is this team actually authorized to actually access this data set, and then that authorizer actually, like I mentioned, a combination of IAM policies and S3 bucket policies realizes that access control in terms of policies, essentially. So when a checkout comes, the dataset service talks to the authorizer, gets the authorization, and then the data is actually transparently decrypted, copied over to the temporary S3 or the EBS, and then the data scientist can use it. The next thing is, once the models are built, then the model repo service implements the models abstraction, and it allows these models to be actually persisted subsequently for deployment. And one thing I want to point out is capturing the metadata of what data sets were used to produce that model is critical, so that when that model is deployed to production, we can ask the question about the service in production, what data sets were used to build that service. Because the data subject request is going to come at the level of a data set, or even at a higher level, like at the level of a customer. Being able to track all of them, the key is that metadata. And then all these things together now, there is a whole bunch of policies around, for example, when imagine a new SageMaker notebook is started by your data scientist, right? He or she needs to use the right kind of encryption keys, set up the right kind of roles, so that these tools can actually assume that role when they access that data set, and everything, kind of the whole machinery of checkout works. All those things needs to be done. What we found was quite often there were a lot of errors that happened. And what keys were used, where the keys were wrong, the roles assumed were wrong, and it's only normal. So one thing that came in handy was to encapsulate all of them into kind of a service catalog, which is almost like a template, if you want to think of it, that our data scientists can just go and like kind of say like, I belong to this recommendation service project, so I use this recommendation service template, and that kind of internally sets up all those things. Also, it enables the ML platform administrators now to be confident that all those encryption requirements and all the access control requirements are all enforced in the right way. So a combination of that actually turns out to be very effective in practice. Then we have the production side, productization side of it, right? Once the models are built, then we have a service that kind of takes this model and spits out a URL that represents a service that can serve predictions out of that model. Essentially, it is like a model in, serves out kind of pattern where the model is wrapped into a RESTful web service and then deployed on Kubernetes as like just straight up like kind of web service wrapped in a container running on a Kubernetes cluster with some load balancer on the top. So that is then subsequently consumed by the application layer. So that kind of gives you a good overview of the ML platform itself and how those requirements are mapped. Good. I have 5 minutes, so I'm going to quickly go. I want to highlight two aspects. One, I think I already touched upon, which is using the service catalog turned out to be a very effective way to enforce the role-based access control as well as enforce the versioning and reuse of the configuration. The other one is a very interesting trade-off that we had to make, which is we have per customer encryption of the data set. The data scientists would like to use SageMaker algorithms, for example, which can consume these data sets and build these ML models. They are super optimized for AWS. What we found was that is in conflict with the per customer encryption because the SageMaker algorithms cannot consume data that is encrypted, each parts of the data set encrypted with different key. So there was that fundamental kind of impedance mismatch that you have. So having this checkout and publish as leverage point allowed us to transparently take a whole lot of data sets encrypted with different keys, decrypt all of them on the fly, create a new data set with just one encryption, and then actually store them in a temporary S3 bucket that is owned by that role, encrypted with a key that role has access, which can be passed downstream to the SageMaker algorithm. And then once that is consumed and executed, you can actually kind of blow that off, the whole S3 bucket if you want. Gives you a very nice way to contain the blast radius of that particular data set that is actually being used. So that was really nice. Then lessons learned. It is possible to achieve privacy and time to market. So that's something that we believed on when we started, and we still believe on. It does not come easily. It has come with a lot of trade-offs, but we believe fundamentally this is the way to build ML products in an ethical way, and this is the foundation for that. Another lesson learned was from the get-go, designing for enabling audits and reviews goes a long way in implementing any of these GDPR or any of the privacy laws, because at the end of the day, when there is an audit that comes, providing that very, very simple question, right? Your auditor walks to you and asks, like, can you show evidence that you as a company used a data set provided to build recommendations for, let's say, your financial products is used only for that? Just for a second, think, how would you implement how would you show evidence like that? A data set provided for a purpose is used only for that purpose. And that enabling complete trail of what APIs are used, in what sequence, what data set is touched, all the lineage tracking, etc. Designing from the get-go like that goes a long way towards doing that. Yeah, and if there is one thing that I cannot emphasize more is It's about that metadata and lineage tracking. That's the linchpin that helps you to kind of wire all of them together to get there. The next one is, if possible, build ground up from ML for ML. So we have had multiple iterations of this before, trying to like kind of slap ML tools on top of a big data infrastructure. Implementing this kind of granular privacy and security on top of that becomes a nightmare. And second, being able to move really fast to leverage some of the cutting edge tools is also very, very hard. So if possible, build ground up for ML. Then leveraging AWS was a good idea. And so would be any other cloud. And this is known for other like standard software development, right? So just for ML also, it turns out to be something like a good idea to kind of leverage. And that's pretty much it. So I hope I was able to convince you that a well-designed architecture can be a key enabler for implementing privacy and security. So thank you. Yes.
Great presentation.
Thank you.
A couple questions. You mentioned audit. I know Workday transaction environment has been audited by a number of, by SOC 2, what have you. That's fine. Is the ML environment also audited within the scope of SOC 2?
Not yet.
Okay. So now the second question, when you move the data from the transactional data sources through all this many iterations of transformations, eventually onto this new environment, did you do any de-identification of the personal data?
Yeah, I didn't cover it in this one, but yes, that is.
You have de-identified.
Yes. So there is a separate pipeline that looks at this data, looks at the PII, does de-identification, etc.
So your ML environment only use those individual records but de-identified?
It uses both.
You use
Yes, it uses both depending on.
Non-identified as well?
Yes, but it uses the raw data that comes in has PII, right? Then subsequently, as it moves through the pipeline, at the appropriate stage, it is de-identified. It could be early on, it could be later, but by the time it gets into the product, into service, it is appropriately handled by that time. So that's what I mean by like it is done at the appropriate time. Because there is a whole lot of stages that is there, right? Yeah.
Thank you.
Sure. Any other questions? Okay, thank you. Thank you once again for staying late and attending this.